Thanks for coming, everybody. Thanks to BSides Las Vegas for hosting me. This is really excited. This is my first talk here at BSides, and I think it's just a thrill to be here. I've really enjoyed a lot of the talks that have been going on this week, and I've had a lot of fun at the Metasploit booth as well. If you want to check it out, if you haven't had a chance, try out the Metasploitable 3 CTF, which you've got running. Get a shell within 5 minutes, and you win a free t-shirt. So. On with the show. So this talk is LibreSSL pushing the ecosystem. The crux of this talk is we're going to be talking about LibreSSL. I'm the portable maintainer for LibreSSL for the OpenBSD project. And we're going to be talking about not so much the project itself, but some of the effects it's had on different operating systems, different sort of programs within the sort of the security tool ecosystem, and the ways that things have changed over the last 4 years. So this is kind of our agenda. We're going to be talking a little bit about introduction to LibreSSL if you've never heard of it before. I'm going to tell you a little bit about it. Talk about some of the things that I work on, which is mostly around portability across multiple operating systems. It's kind of an unsung job, but I kind of enjoy it, partly because I'm a glutton for punishment. We're going to talk about 3 different stories that sort of mention things that are difficult within the portable realm and ways that we've addressed it within LibreSSL. And we're going to be talking about ways that operating systems have evolved to make things easier for us. We're going to be talking about arc4random, which is the entropy generator for LibreSSL. I know entropy generation may not be the most interesting topic to a lot of people, but it's a really fascinating topic, especially when you're trying to be secure about it. We're going to talk about the ways different operating systems approach it and ways that we've sort of worked around deficiencies over time. We're going to talk about environment variables, which everyone, I don't know, does anyone here like environment variables? I know you do. I know you do. And so we're going to talk about some things that can be bad about environment variables and ways that we've worked around them, and some other projects that you may be interested in learning about. So LibreSSL, it's a 4-year-old fork of OpenSSL. It came about right around Heartbleed. When Heartbleed came out, the OpenBSD team started auditing OpenSSL and said, there's a lot of bad code in here. We've been just kind of blindly taking that faith that this is well maintained, that this is secure. We're going to start ripping out all the obsolete broken code out of this system, and we're going to build our own version called LibreSSL. A lot of stuff's been deleted. In fact, I think, what is it, probably like about 500,000 lines or so that we've deleted over time. We've added a lot of new features as well. We were one of the first SSL forks to have crypto support like Cha-Cha-20. We were basically one of the first to come up with a better API for OpenSSL as well. We have an API we call libTLS, which is a simplified API that makes it a lot easier for software developers to not shoot themselves in the foot when they're writing secure software. One of the other kind of neat things about LibreSSL, and this is something we've evolved over time, is it actually has full software compatibility with OpenSSL 1.01, 1.02, and 1.1. So you can basically write software for any of those APIs, and they all work with OpenSSL directly. We work very much in lockstep with OpenBSD team. Every 6 months we put out a new major release. We have about 5 or 6 people that work on the core pieces of LibreSSL over time. It kind of is a rotating crew. One of the neat things about the OpenSSL or LibreSSL development is that anyone within the OpenBSD project can contribute to it. We don't really have sort of a huge separation between who's like an SSL developer and who's not. Actually, generally within the OpenBSD project, the last person to have touched a file gets to become the de facto maintainer of that file. So if you ever want to accidentally become the NFS maintainer, commit some code to it, and then you get to win that as well. It also has some interesting features that were added to LibreSSL, like privilege separation and isolation that's sort of specific to OpenBSD. Like, for instance, it uses the pledge command quite often to automatically lower privileges that are used within the project, and we'll go into that a little bit later. So one of the things that we approach with LibreSSL, especially when we started the original fork, was we noticed that OpenSSL doesn't trust operating systems very much. It implemented its own memory allocator, which is one of the reasons why Heartbleed was exploitable within OpenBSD, because it basically circumvented a lot of the memory protections built into OpenBSD. So one of the things that we did first with LibreSSL was we got rid of a lot of the kind of duplicate implementations of things like memory allocators or things that don't trust the operating system to do something right. In places where the documentation was wrong, we fixed that as well. In fact, a ton of work has gone into LibreSSL's man pages. I know that doesn't sound like super sexy either, but I think LibreSSL has some of the best OpenSSL man pages around. And if you just take a look at the number of commits that go into the man pages, it's pretty incredible. We've also tried to remove all the broken APIs and all the unsafe APIs. This is sometimes a give and take because you might find that within the software ecosystem that certain APIs used a lot. Because OpenBSD is an operating system into itself, it has about 5,000 to 6,000 ports that it needs to work with, and this is the base SSL layer for it. So generally, we find out really quickly if we remove a bad API and someone's actually using it. A lot of times we actually work with those upstream maintainers and fix their software upstream so that they're not using a bad API as opposed to just continuing to let the status quo move on. So really one of our goals isn't just to make LibreSSL a good project, but to actually make the entire ecosystem a better project by working with upstream maintainers, working with other software, and making them better at the same time. And it's a big effort. It's a huge team effort. So how did I get involved with this? I worked at a company called Boundary, and I worked on our agent. We wrote an agent in C that basically monitored network traffic and sent it all up to the cloud to be processed. And all the software that we had as part of our agent, you could configure it and build it like this. If you've ever built software on Linux, configure, make, install. It's easy, right? Except when you built OpenSSL, you had to create these huge monstrosities of patches and huge crap to turn off all the broken stuff, and no heartbeats, no engine, no Kerberos, no SSL v2. So basically, they kept so much backwards compatibility that they just kind of paralyzed and never moved forward. So I didn't like this, and it didn't happen to have separate build steps for everything. So really, my interest in LibreSSL was really just to make it easier to build software. I wasn't really into the security part initially. Later on, I got into that. But effectively, that's the reason why I got more or less recruited by the OpenBSD team to work on this project. Right when LibreSSL came out, originally they said, it's only going to be for OpenBSD. We don't care about any other operating system. And so as kind of a dare, I said, well, I wonder if I could make it work for this Boundary agent, And basically I sat down for a couple weeks and I wrote, I like AutoConf and AutoMake. I don't know if anyone else here likes those things, but they're not too bad. You learn a little bit of M4 scripting and, you're off to the races, or sort of. And so anyway, I was on vacation with my family in Japan, and Theo the Rat starts emailing me and says, hey, you want to work with us and make a portable version of LibreSSL? And my family was all jet lagged, and they were all bouncing around. So I just would go down to this cafe, the Sakura Cafe in Ikebukuro, and I would just hack all night when we were in Tokyo, and worked on basically talked with those guys, and we ended up deciding to meet in Slovenia in a couple months. So basically, I'm just talking to these random people on the internet, and they're like, "Hey, come to Slovenia and hack with us." And I've never been to Europe before, so I just decided to go. And as people know, I'm usually not a very adventurous person. I don't do things just on a whim. But in this case, I went out there and met like 70 or so developers. We hung out in like a co-ed hostel and did a bunch of hacking with Bavarians. So it was a lot of fun. We got our first like 5 or 6 releases out that week. I learned how to use CVS, which I don't know, I hadn't used that like since college or so. But we got it all hacked up, pushed it out, and then we got our first. Well, okay. First of all, I just talking a little bit about LibreSSL again. We support a lot of different platforms. We support Windows in like 4 or 5 different incarnations. AIX, macOS, FreeBSD, HPUX, Linux, NetBSD, OpenBSD, Solaris. We actually support some weird stuff like Sortix and MIDIPix, which is also another Windows layer. We had 3 different build systems. We have the OpenBSD source tree, which is how normally it gets built, AutoConf, and we even support CMake. Have you guys ever used CMake before? It's a pretty cool project. I really like Ninja, especially, doing Ninja builds. Everyone in the OpenBSD team is really jealous when I can build LibreSSL in like 25 seconds and everything else takes 5 minutes. This is kind of going to circle back to that first week where we sat down in Ljubljana and got those first patches out, those first releases of LibreSSL out. And that is the idea that making things compile is easy, making things work correctly is really hard. basically, how can we make a portable version of LibreSSL that doesn't drive us crazy, doesn't require a bunch of if-defs and defines? How do we make it so that we don't have to have a ton of patches all over the place to make this thing work? One of the approaches that we took to make this stuff happen is we actually have this concept of, I guess you could call them intermediate headers within LibreSSL. What it basically does is whenever LibreSSL tries to, is anyone here a C programmer? Just to kind of start? All right, so I'm not going over too many people's heads on the whole include things. What the idea here is that there are definitions of the way functions look within the operating system in these headers. And what you'll find is that a lot of times these vary from operating system to operating system. Sometimes there's a function missing, sometimes the definition's a little bit weird, sometimes there's a whole subsystem that's missing from an OS, whether it's Windows or Linux or whatever. And so you have to fix it. And so how do you fix it? Either you write in your C code a bunch of little conditionals like, if it's Windows, do this, if it's not Windows, do that. Or you can actually intercept all of the includes that happen within the build system and include your own version that automatically fixes all the system calls for you. So like for instance, whenever we do time-related functions within LibreSSL, it includes time.h, but it actually includes our own specially modified version of time.h, which has all the missing pieces already incorporated into it. And then we have this kind of interesting code here. I'm going to point it out. So what this basically does is it uses an interesting little function that you may have never seen before, or a directive called include next. And on every compiler except for Visual C, include next will automatically include the next header file in the path. So it basically allows you to create an interceptor that grabs, that sits between the real header and the header that you want to modify, and lets you mutate the effect of including that header. And of course, these other little things are kind of a weird hack of a trick. So if you include sort of a relative path, you can trick Visual Studio into thinking that's actually a different header altogether, and get around the limitations there where they don't have include next. So that's really how we do it. We basically, rather than coding around, like say, Windows missing fopen or fopen not working properly, we actually define our own version of POSIX fopen that acts like POSIX, and then redefines what fopen is inside of Windows code to look like the POSIX fopen. This basically means that the core code of LibreSSL has no if-def windows in it. And that's kind of a goal of ours, is to make it easier for developers to develop code without having problems where one section has one behavior, another section has a different behavior, and it just becomes kind of a spaghettified mess. So that's one way that we've been working to get the operating systems to sort of be the same. Ideally, there's nothing in there at all. Another way that we have managed to make portable LibreSSL work well within different operating systems is we do sort of runtime detection of operating system attributes. For instance, a key function that we use within LibreSSL for doing entropy generation is a function called arc4random. Now, arc4random is supposed to be a very secure random number generator and really easy to use. It doesn't even have a failure mode. There's no way for it to fail. There's no return value you can give that isn't supposed to be completely random and unpredictable. Now, occasionally people make mistakes and implement it badly. And that's the case, then we actually have code within LibreSSL that can detect, like for instance, if you're running NetBSD before version 7, arc4random was broken because they actually used a copy from OpenBSD from like 10 years ago, and they never updated it. Now, eventually we worked with the NetBSD team and updated it so that they did have a working version of arc4random, so there's actually code within LibreSSL that automatically patch in and out arc4random depending on if the underlying operating system is sufficiently good. Another thing that we do is we continually monitor upstream code. It's really nice that a lot of people are open source, so we can actually see if things change over time. And in fact, as part of kind of our LibreSSL porting plan, we've seen a lot of operating systems adopt things that we've sort of been pushing. And it's been kind of rewarding to see that happen in reality. I'm going to talk about 3 different stories of this kind of ecosystem push happening in the real world. First one is around clearing memory. And keeping secrets. So when you have a crypto library, oftentimes it's very important that things like the secrets that you decrypt don't hang around in memory. Normally, the operating system will have like a free command that lets you free the memory back to the operating system itself, but that doesn't necessarily mean that it goes away. Someone else could reallocate that memory and get that secret right back. So you want to make sure that you clear things securely. And it's actually surprisingly hard. So in 2014, LibreSSL, when we started working, we found a lot of code like this inside of OpenSSL, basically calling memset. Now memset is a C function that's supposed to clear out memory. However, the compiler can be really smart about it. According to the standard, the compiler can say, if no one actually ever reads the memory, then why bother clearing it at all? So it can actually detect if, it's like for instance, if buffer never gets read again after it gets written to, then it can actually optimize that code out. And a lot of compilers will do that as soon as you turn on any optimization. So how do you stop the compiler from doing it? Well, compilers are going to compile. So sometimes what you have to do is you have to trick them and to make sure that their optimizer can't tell that you didn't read it later. So for OpenBSD 5.5, we implemented a function called explicit B0, which calls B0 but calls it with one level of indirection. So basically the underlying function can't be seen, so it doesn't know if you read it or not. However, it turns out this is defeatable easily by something called link time optimization, where you basically, after you compile the code, when you glue it all together with the linker can go, oh, well, then no one really did ever read this code after all, or read this memory, so it optimizes out your memset, or explicit B0. So how do you fix that? Well, NetBSD tried to fix it by adding a bunch of void star pointers and making the memset function itself something that could be replaced. This is interesting in that, one, it makes it so that you can actually replace memset with any function you want. So you have a nice sort of hook for all the secrets within your program. Another neat thing about this is that it doesn't always work either. So back to the drawing board. Something else that we tried, actually here I'm just talking about this, the biggest problem with this is it creates a nice little wrap gadget that you can use within all your other code. Something else that we tried was this. So basically creating a weak function. What a weak function is, if you're basically giving a hint to the linker that this function can be replaced at any time at runtime with another function. So it basically prevents the link time optimizer from being able to do its work and prevents it from working. However, there's still an arms race that you have to do. It turns out that the latest versions of GCC and LLVM and all that kind of stuff will still look to see if this works or not, and will potentially replace it with their own versions. So one of the things that we did to continue sort of pushing the arms race forward is try to convince everyone, first of all, that this is the right way to do it, but also creating a way to, let me see, go forward, a way to actually test it. Let's see if we can go to the place where we were testing it. I didn't include a slide on testing it, but the way that we actually ended up having to test this, and so like, how do you know that the compiler optimized something out or not without actually building the code and testing it in the first place? The way that we figured this out was we wrote something that used signal handlers and created an alternate stack and would change the memory in the alternate stack and then would signal the signal handler and check to see if the stack changed under the covers. And then if that happened, then we knew if the compiler optimized the code out or not. One way that we work around the compilers themselves being extra optimized is we actually have a separate library that we link into LibreSSL that has all the optimizations disabled. And if you do that, that for now convinces most compilers that you shouldn't optimize this code out. Something else to note is that at least as of 2016, we didn't have any explicit B0 or explicit memsets inside of glibc. Now, glibc 2.24 did eventually adopt this. They ended up doing their isolation in a completely different way because there's a little bit of not invented here syndrome amongst a lot of different operating systems. But at least they sort of adopted the API and sort of accept responsibility for implementing it. Now, there's still problems with this. There's a recent Usenix paper about dead store elimination still being a problem within a lot of secure software. So strangely enough, this is still a problem in 2018 with different pieces of software and different compilers. Something to note here is if you read the current Linux manual for it, it actually still says explicit B0 can decrease your security if the compiler is determined enough and decides that all your data stores in a register, then you can't optimize it out. So it's kind of one of those damned if you do, damned if you don't kind of things. Something funny to note is that if you do this on Windows, it works perfectly and has for like a decade because they had a secure zero memory function for a long time. They recognized this as a problem. And so when we added explicit B0, porting it to Windows was a piece of cake. And you'll find this is actually a continuing theme in the Windows thing. So arc for random. Entropy is hard, but why does it have to be so hard? So prior to LibreSSL existing, OpenBSD or OpenSSL did a lot of weird stuff to create random numbers. It would do a little bit of stack, it'd do a little bit of PID, it would try to get things from good places, and, dev random and stuff like that. And if that failed, it would always fail kind of crappy. So there was a lot of problems where there was just a lot of extra complexity in the entropy generator in OpenSSL. And in fact, that's kind of a continuing trend. They actually recently rewrote their entropy generator, and it's just as complicated and just as prone for failure. Something we did in LibreSSL, we actually simplified it down to this. In fact, our entire PRNG system inside of LibreSSL fits on this slide. We took out the ability to seed it. We took out the ability to add entropy and said, darn it, we're going to trust the operating system to do the right thing and always give us random data. So we just call arc for random buff whenever we need random bytes. Now you might ask, well, what if it does fail? Well, arc for random is defined as not being able to fail. So if it can't generate random numbers, it actually will crash your program. There's no other alternative to it. So we'll talk a little bit about the primitives that go with that. So in 2014, when I was doing my original port, my first thought was, well, shoot, I need an arc for random that works on a lot of different operating systems. Where am I going to get one? Well, there's a program called LibBSD. You might have seen it before. It's actually still shipped with a lot of operating systems. And I didn't bother looking at how it worked. So anyway, I incorporated it and assumed that the upstream developer had implemented arc for random well. But then someone wrote a blog about my port and told me how insecure it was and how terrible it was, and then said basically, this guy doesn't know what he's doing. And so I went looking at it, and yeah, it calls get time of day and get PID and mixes it together. And that's not great because it creates very predictable entropy states, almost Debian level, but not quite. And so anyway, it was nice to be able to read a blog post and be semi-internet famous for a little while, but we went ahead and fixed it. So take two. Well, I found the code from OpenSSH, and I thought, well, those guys know what they're doing, right? I'll use their code. But it turns out they used OpenSSL's random number generator. So it's kind of a chicken and egg problem. So screw it. I'm going to use this guy, this thing called LibOttery. That looks really good and complicated. I don't know. But if you look up LibOttery, you can look up their GitHub page. It basically says that your eyes will bleed and monkeys will come down from the sky if you use this for anything that actually needs security. So what do I do? So anyway, this is actually kind of cool. The OpenBSD guys actually came to me and said, hey, we'll help you figure this out. We will build hooks into our random number generator that allow you to hook into OS intrinsics and write your own portable versions. In fact, we even got the OpenBSD team to write Windows code. So if you look in the OpenBSD tree under libcrypto, there's actually versions of arc for random for 6 different operating systems in the OpenBSD tree. And those are explicitly there for anyone to use within their code or within their own portable libraries. And we put that there intentionally hoping that people would notice it and would say, oh, here's how we can generate entropy random numbers well and in kind of a predictable and non-fallible way. Whether people actually pick those up or not is an open question, but we tried our best. One of the things that arc for random does that's also important is that every time you fork a process, it automatically clears out its state. That way, if a child forks from a parent, you don't end up cloning the crypto state, and you don't end up say if you're both generating an RSA key or something like that, you don't end up with the same key simultaneously. So one of the things that OpenBSD has is that you can allocate memory that never is inherited by your children. Right? It's just a simple mmap flag, and so that's how they do it. But it turns out that other operating systems don't have a reliable way to do that. Another thing that OpenBSD added was a call called get entropy, and this is a call to the operating system. Again, a call that cannot fail, and it returns up to 128 bits of entropy. And that's supposedly all you need to seed a random number generator. We gave it out there again to hopefully other operating systems would implement it. And unfortunately, there really wasn't a great way to do it in any operating system, at least not in 2014. So some of the things that we did to implement ones that would work well, you see this get entropy linux.c. There's a lot of sausage in there, or I guess sausage making going on in there. Under the covers, what it does is it basically can't get random numbers from dev-urandom, which is supposed to be secure on Linux. It tries deprecated syscall. If that doesn't work, it falls back to the most crazy, well, it's really a best effort. It's better than PIDs and get time of day because it actually looks at like your ASLR. It looks at things that are pushed onto the stack. It looks at the entropy that comes from your memory allocator. It looks at a lot of different stuff. But in the process of generating this, better fallback, you can see multiple orders of magnitude slower. So you don't want to hit this if you don't have to. But we started working with Ted So and got something like get entropy added to the Linux kernel. But unfortunately, they decided to implement something a little bit different than get entropy. Normally, OpenBSD requires that you not ask for more than 256 bytes of entropy at a time. And the whole reason for that is so you don't end up with exhaustion of your entropy generator. Over time, it took a while for others to adopt it. And about the only OS that didn't quite just adopt it exactly like we specified in OpenBSD was Linux. And that's because a lot of people decided that they needed to create Monte Carlo simulations and they needed lots of weird little tweaks. And what if I need more than 256 bytes? I don't know. We need to make it generalized for everybody. So I ended up adding something called get random. Does anyone here know get random? Oh, okay. Adam knows get random. So anyway, a committee got involved. A bunch of people started making requests, and we ended up with something called get random. Get random is okay, but it has a lot of failure modes. And we get a lot more ways to exercise our fallback code in that particular case. If you followed, like, say, Python or Ruby or a few different languages that end up being used in like systems, not necessarily systems programming, but like early in the boot process, you might have noticed that there's been some bugs that have come up with get random in early entropy generation and that sort of stuff, just because it can fail or it cannot fail, and it might hang and it might not hang, and so there's a lot of issues with it. However, it turns out that Windows had a built-in way to do this all along, and so you call crypt gen random, and you get a perfect random generator, at least one that we're currently trusting the OS to provide it for us. Like I said before, we have 8 different implementations of get entropy. Again, they're all in the OpenBSD tree. You can use them. I believe FreeBSD, Linux, NetBSD, OS X, and Solaris have all implemented since then their own versions of get entropy. And so that basically means that the LibreSSL code does not ever call any of these fallback functions if those other versions are available. And that's actually pretty cool, because that means that now these kind of secure, easy-to-use crypto primitives are now available in a lot of operating systems, partly because we pushed LibreSSL out into the ecosystem. In 2018, where's Arc4Random? Now, a lot of people think, oh, LibreSSL, all you guys need is get entropy to work. Well, actually, I don't want get entropy. I want Arc4Random, which is really the user space API that you want for generating random numbers. We still have some blacklists. OS X, at least 10.12, still had or 10.11 had a non-compliant Arc4Random. They had some problems with reseeding. FreeBSD I thought worked very recently, but I tried it again recently and it still fails all the fork tests. NetBSD 7.0, Solaris, a lot of them now actually provide Arc4Random, which is really great. I like the fact that now that's actually available. Unfortunately, did I include that? Yeah. We tried to get Arc4Random specified as an actual standard. And because a lot of people objected to the fact that it had the word Arc4 in it, which implied that you should use Arc4, it doesn't actually use that algorithm anymore. A lot of folks kind of balked at it just based on the name. Unfortunately, it got stuck in committee. And so it sort of sits there for the last 4 years, and it's not really moving forward. So hopefully, it'll just become an ad hoc standard, and everyone will implement it. Here's one of the PRNG bugs that recently came up on the dev mailing list with regards to get random, or what was it called? Get random, or yeah, with regards to the Linux PRNG having early initialization issues. Now, all hope is not lost. There's actually a glibc patch that's current for that's sitting in the patch queue for implementing Arc4Random. Maybe about 20 years after we've implemented OpenBSD, it'll show up, but we'll see. If you ever implemented Linux from scratch, it does include it as a patch by default, which is very nice. So one final story of ways that we sort of move the ecosystem forward is around environment variables. So if you ever used OpenSSL in anger before, you might have noticed that there's a lot of environment variables that change its behavior. It's not really a great idea for libraries to be tweakable by the user based on environment variables. So there's a lot of issues with different OS vendors, like Red Hat patches their OpenSSL to be able to respond to Red Hat specific environment variables. There's a lot of problems with processes that raise privileges, whether or not they look at their own environment variables or they forget ones that are unsafe is kind of an issue, especially if like a set UID binary that a user controls. So under the covers, OpenSSL uses kind of an ad hoc version of a function called isSetUGID. Basically, the idea behind this function is if a process has ever escalated privileges, isSetUGID should be set. So basically, if you've ever escalated to root, maybe if you come back down to a regular user, if you have an escalatable process, it needs to always have isSetUGID set, because that will mean that you should not trust any of your environment variables. Basically, that trust has been breached. What we found is that this function is broken on a lot of operating systems. Most of the BSDs in macOS implement it as a syscall. Almost everyone else implemented it as kind of an ad hoc libc function, which had a lot of actual time of check, time of use functions. If you look at this function here, this is a simplified version that was in OpenSSL. It would basically check to see if my user ID is my effective user ID and my group ID is my effective group ID. But you can actually be changing both of these things while you're running this test, so it can actually fails open, which is not a great thing. So one of the first things we did was like, how can we implement this in a way that actually is 100% reliable? For instance, on Linux, glibc had this thing called getOxval, which you may know there's 3 different sets of arguments that get passed to a program. There's the program's name, the argument list, like argv. There's also something called the auxiliary vector. And what this is a list of operating specific arguments that get passed to any sort of ELF binary that have things like random number that seeds my memory allocator, or what is the base vector of where I need to like start loading libraries. One of them has this AT_secure, which basically says, is this a set UID binary or not? So that seemed like a really good alternative to not having a syscall. However, it turns out that getOxval, when it fails, also returns 0. So you can't tell the difference between a failure and actually having like a privilege escalation or not. So eventually they fixed that in glibc 2.19. So you actually have error checking at this point. But you ended up with code like this, which also wasn't that great and wasn't necessarily the right approach. There's also in glibc something called secure get env, which actually it turns out is insecure, aside from its name, because it actually has the same time of check, time of use issues that we just talked about a second ago that were in the underlying OpenSSL library. So we'll go down a little bit deeper, and we'll check to see if it's even possible to overwrite it. So it turns out you can, because it also sets an internal variable, you can actually just reference it and change it on the fly. So you can actually tweak your programs to be up and down, and change where this libc enable secure function or variable is. So fun stuff. Other operating systems, during the process of doing the porting, I actually found a bug in FreeBSD's implementation in that AT_secure always lied. And the reason why they did this actually was to speed up threads, pthreads in their Linux emulation layer. It took them only 2 years to fix the bug, but they did eventually, and there's the security advisor. So it's literally the only FreeBSD security advisor I have under my name, but I'm pretty excited. It turns out like 5 other people also reported it, so glad they fixed it. So it turns out because there were so many bugs in isSetUGID for different operating systems, macOS doesn't work past the fork, Solaris didn't work before 11.1, HPUX was actually perfect, which is kind of weird, but I'm happy for those guys. AX had so many failure modes. They have like, it's basically Unix written by aliens, so they have so many different ways to like escalate privileges, and like it's very not Unixy. So I just didn't even want to get into it. So basically, because they're also broken, we implemented isSetUGID as, yeah, everything is always unsafe, never trust environment variables. So we set that, waited for a year, waited for someone to scream at us. No one did. and we deleted all the environment variable usage out of the entire library. So, ta-da! So that's good. We actually use this approach quite a bit. Now, this one was kind of an accident because I had actually had a bug in my configure script where it automatically assumed everyone was broken. But because no one screamed, I was happy about that. So some other interesting things that we've done as far as sort of moving the community forward is, and this is kind of a controversial decision, when we first put out LibreSSL, we called the OpenSSL version 2. And initially that was just kind of a funny joke, and that we were just like, oh, they'll never put out version 2, so we'll go ahead and claim it for ourselves, and then they'll have to jump to 3 when they ever get to 2. We estimated it would take them 25 more years to get to that point, so it wasn't going to be a real problem. But it turns out that a lot of software under the covers uses OpenSSL version to determine if features are available. Like, rather than saying, do I have this function, it says, oh, is OpenSSL version greater than 1.0.2.b or something like that. And so this caused a lot of random software to fail over time, to fail to compile. Now, mostly this was like the job of our porting team to fix this with patches. But our real hope was that software developers would stop using SSL version as a signal and would instead actually check to see, like, is a function implemented, is it not implemented? But no one ever did. And in fact, to this very day, we continue to push patches up to upstream projects. Nginx is actually a current one that we're working on right now, where they just trust OpenSSL version to mean something, and it doesn't necessarily mean anything at all. Something else that we've been working on a lot lately has been OpenSSL 1.1's API. Does anyone here actually code against OpenSSL and kind of know the differences between 1.0 and 1.1? So the big differences between the two are, for OpenSSL 1.1, they decided to make all the C structs opaque. And what that means is that you can't access them directly from within your C code. So if I have an SSL context or something like that, and I look inside to get like the version, I can't look at it anymore. Instead, I have to use an accessor function to get access to it. Now, you might ask, well, why did the OpenSSL team decide to change this from I can access structs to not access structs? Well, I actually found out. I went to the International Cryptographic Module Conference earlier this year, and I asked Rich Saltz why they actually did this. And it turns out it's for FIPS compliance. So because with FIPS compliance, you don't want to have to change your binaries. You don't want to have to change your ABI for compliance testing. When you have open structs like this, every time you want to add a number, remember, it changes your ABI. By hiding it like this, it means that they can actually push out new FIPS releases without having the whole thing recertified. They can just recertify one object. So that's actually the underlying reason. It was for FIPS compliance. Now, this wasn't really advertised that much, but it was interesting seeing all the really, really distraught government cryptographic software writers worrying about the OpenSSL 1.1 jump. So for LibreSSL, we don't care about that stuff. Well, FIPS, I mean, partly because it's a lot of work and not a whole lot of gain from our point of view. But the other thing is we don't care that much about ABIs and APIs. Well, I said that wrong. We care a lot. We care a lot about not breaking people's old APIs. So we try to keep every old API available. That's why LibreSSL actually works with 1.01 code all the way to 1.1 code, because we actually incorporated all the APIs at the same time. So LibreSSL basically supports all the APIs simultaneously. Now, another reason why the OpenSSL team decided to make opaque structs is because every time they changed the size of their structs or added a new element or something like that, all code had to be recompiled. That's because they never changed the version number in their libraries. If you have OpenSSL 101, it's always called OpenSSL 101, even if they add a function or remove a function. So that causes problems when you have to tell everyone to recompile. LibreSSL actually bumps the library version number every release by at least 4 or 5, because our philosophy is every time you change the ABI, you should bump the version number. So while LibreSSL is currently at version 2.8, I put out the release notes for that today, the underlying library version is like 1.57 or something like that. So we're like major version 57 because we bump version numbers. But the neat thing is you can actually have all the versions of LibreSSL installed simultaneously. So you don't have to recompile your code. You can actually keep everything pointing to the old version, the new version, things like that. I've worked with a lot of Linux distributors and other folks and said, hey, why don't you just incorporate some way for your package manager to install multiple versions of a library, no one wants to do it. I don't understand why, but that's the breaks. There are some brave Linux distributions that do incorporate LibreSSL, and when we put out a new release, they just recompile all the software. But you know what? Updating 100 packages on your machine isn't that big a deal anymore. Maybe back in the modem dial-up days it was, but think about like your normal like Debian distribution or following Ubuntu. What do you have to do? Install like 400 or 500 packages just after the main install? So update. Another thing that we've been working on a lot is software configuration management. So we've tried to make it so that it's easy to incorporate LibreSSL with different software. A lot of work's been going into the CMake subsystem. We get a lot of feedback. We finally have a lot of Windows users. I don't understand why, but a lot of folks use it. And one of the main reasons is actually because we were producing an OpenSSL.exe, which is very useful. Turns out some people said, if you put that in the Windows Store, I would buy it. So we may have a new revenue source for LibreSSL in the future as well. Just compile some EXEs. So that's really the gist of it. I have lots more stories to maybe talk about if you guys want to sort of, ask me after the talk or something like that. I also have a lot of different other projects that we can also talk about a little bit offline. libTLS, which is our simplified abstraction layer on top of OpenSSL, it basically makes it really bulletproof to get a secure application running within C. We also have Go bindings, we have Python bindings, and I forget a couple of other languages, but those are the main ones. We have a Netcat. So you guys like Netcat? You guys are all hackers, right? So actually, LibreSSL ships with Netcat, but it's a special Netcat that knows how to do TLS as well. Now, you might have used, what is the one that comes with Wireshark? Is it called NCAT? Yeah. In MacCat, I forget. Anyway, so similar to that. If you compile it with like enable netcat, it'll actually install it for you. So if you want to use the cool enabled netcat, we actually use it for all of our testing because it actually has every feature enabled. So you can enable OCSP stapling within netcat if you want. You can do all kinds of crazy stuff. We have a whole bunch of other cool stuff too. We have an Acme client, which lets you do Let's Encrypt with the C. It uses LibreSSL under the covers. We have a special OpenBSD HTTP server. I've got a portable version if anyone's interested in it. That lets you basically, it's just a simple HTTP server, but the idea here is that the main goal is it supports really good privilege separation. So it actually has like one process that's in a sandbox that can't do anything, but it can serve files, another one that can really just bind to a port, and then like a third one that handles all the configuration management. RelayD, which is a gateway load balancer, same kind of thing. And I'm also the maintainer for OpenNTPD. Well, you might wonder why an NTP client would be here. The NTP client actually doesn't trust NTP servers by default. It can actually ask random TLS servers if they also collaborate that the time roughly matches what the NTP servers are saying. So OpenNTPD by default can, for instance, talk to Google, look at Google's headers over TLS and see what time it says from that point of view and see if your Netcat, if your NTP servers are lying to you or not, and will automatically desync if it turns out that they can't reach a consensus. And one of the biggest problems with that reasons for that is because NTP itself is not really a secure protocol, and there's been a lot of work on like a secure version of NTP, but it's never really been successful yet. So anyway, that's my talk. Thanks for coming, guys, and let me know if you have any questions.
Thank you. Quick question on failing when you run out of entropy, crashing. So if I don't want my program to crash, do I have to wrap, I can't remember what function was it, ran bytes? Do I have to wrap it with like set jump, long jump, or what are my options? So
the interesting thing about this function, and of course it's open source, you can check it out, is it actually only ever seeds itself at the very beginning. So whenever you first start your program, it will either seed or it will fail. And basically after that first set of entropy, it's now stored within the state of arc4random, and it uses cha-cha-20, I believe, to actually produce the rest of the byte stream that ends up being used for the real random number generation.
So it'll crash right at the beginning or not?
That's right. You either completely work or you completely fail, and there's no in between, like I might fail in a day or two or like that.
Do you think there's some cases where blocking could actually end up getting the entry pool filled up?
Yeah, absolutely. So our get entropy is supposed to block. It needs to block until it gets the data that it needs, or if it literally can't be succeeded, then it will fail. Inside of OpenBSD, it's not a problem because OpenBSD always reseeds its random memory generator from the bootloader into the kernel. And whenever it reboots, it saves the last state of the random memory generator in a file that the bootloader knows how to read on the next reboot. So it's basically kind of a cyclic issue. In Linux, it's not so much the case. It will block until it's got enough entropy from, I don't know, network, disk activity, stuff like that. But this is really a problem in a lot of like cloud environments where everyone boots and there's like no entropy coming into the systems. And so in that case, currently, LibreSSL's implementation will fall back to that kind of crappy 67 per second, fallback, which under the covers is really still asking Linux for entropy anyway. So it's kind of, it turns out it works. Maybe due to a quirk in Linux. What we'd really like is for Linux and other operating systems to implement get entropy to have some way to reliably seed their entropy generator on boot. I don't think anyone's really solved that problem. One of the hesitations, at least that I've heard from the Linux community, is because the kernels, the bootloaders, the libcs, the initrds, all those kind of things are all maintained by different people. No one really wants to work together to come up with a solution. So that's the crux of the problem right there.
Hi, thanks for the talk.
Mm-hmm.
Did you LibreSSL guys do anything with the ASN1 code?
Yeah. One of the first things we've been doing is we have unrolled all the macros. So one of the biggest problems is that like the C code is all metaprogrammed and is kind of crazy in that you can't tell what's implemented where because you have to follow 4 or 5 different macro levels just to read it. So actually, Joel Singh actually unrolled all the macros in all the ASN1 code to just to make it readable in the first place. In addition, we've been doing a lot of work to make it more memory safe. We've removed a lot of the allocations and deallocations from that code. We've had a few foibles along the way. We've tried to simplify things sometimes and have failed, especially with regards to like certificate validations. Date time is another issue that's interesting in that when we're looking at the different versions of dates, 32-bit, 64-bit dates and that sort of thing, we didn't want to add 32-bit compatibility code to LibreSSL just to have, again, we don't like if-defs all over the place, and we really wanted to sort of try to get everyone on 64-bit time Ts. And right now, LibreSSL has some workarounds for 32-bit code, but they're very minimal. And we throw a big warning whenever we compile on a 32-bit system that doesn't have 32-bit time T that, hey, this will stop working in 2030-ish, and you better fix your system before that time.
Hi, so this is less about like LibreSSL portability, but like TLS 1.3 just got ratified.
Yeah.
And like LibreSSL compared to like OpenSSL and boring SSL kind of tends to be more conservative with implementing drafts of implementations. I think that's great. But now that it's been ratified, and OpenSSL has it or in their beta, and what does that timeline look like for LibreSSL? Are you waiting for OpenSSL to get out of beta 1.1.1 or like are you trying to match compatibility with OpenSSL or just kind of waiting to see what happens? I
would say, like a lot of open source software, a lot of it's written to scratch a personal itch. So a lot of the folks that develop LibreSSL do use it in like say some business capacity. Maybe they build like routers and stuff like that on it. But no one internally really has like that itch that they need to scratch for building OpenSSL, or I'm sorry, SSL 1 or TLS 1.3 compatibility. But we are having a hackathon next, I don't know, March, February, something like that, and maybe we'll get together and figure it out.
I'm telling you, that 0 round trip time, you got to get it.
Exactly. Right? I guess it kind of depends. If someone wants to sponsor this, maybe let me take a 6-month sabbatical or something like that. Well, I don't know, Caitlin gave me a weird look. Anyway, yeah. So it really kind of depends. Occasionally we do sponsor people to just hack on things and fix them up. It's in the realm of possibility.
For your For your random number seeding, have you ever worked with the hardware random number generators?
So the random number seeding trusts the operating system to do the right thing. If your operating system uses, say, Intel's random number generation code or ARM's or anyone else's, we're going to trust the operating system to do the right thing. I forget if OpenBSD itself actually includes it, but it certainly doesn't solely rely on it into its entropy generation. I would say that most folks that use, like, say, CPU generations, they still always whiten it with some sort of other source and don't trust it as the sole source. Make it so that, when some random thing comes out about it just doesn't work, or maybe maliciously, unintentionally, whatever, we're not sort of have all our goodies on one basket. But effectively, that's kind of for the implementer to decide, and not really something we're trying to be opinionated about in LibreSSL.
So we did run out of Entropy when it was kind of a cloud-based solution. It was running on a hypervisor. We ran into a couple things. We ran into older hardware versions of the VMs where the things that Linux used to generate entropy weren't available in the virtual chipset.
Yeah.
So that was a bummer. And then we learned that if there's a lot of programs executing because of what you pointed out earlier, that they use random numbers for loading the programs, you could also run out of entropy. So it's kind of important to keep an eye on that in your program.
Right. And I think one of the advantages of the arc4random approach is that you'll never see a individual process use more than 256 bytes of entropy. Because that's all I think it only grabs 128 bytes to seed in the first place for arc4random. Does it once and it's done. So your program shouldn't run out. Now, obviously, there's the forking issue, which could be another problem. And there's not really a good way to get around that right now. I think it's important that the program's blocked rather than failing open. But I guess maybe one other thing to note about arc4random is that if you never call it, it never gets seeded either. There's actually a mutex around it, and it checks to see if it's been seeded once before or not. And if it never gets called, then it never becomes a problem. Any more questions? We just got a couple more minutes left. If not,
Related to some of these questions, Relate to some of these questions, who would you trust from an audit perspective? Is there an organization that says, we looked at these 32 random number generators, we generated 1 trillion random numbers from each one and verified which one seemed more truly random? Is there a source that you would feel trustable on that idea?
Well, I have to say that a lot of folks trust Daniel Bernstein for a lot of this kind of stuff. He's sort of our, I don't even know what the word is for someone that everyone trusts. Anyway, that's one of the reasons why we use Cha-Cha-20 for our underlying byte stream. As far as the rest of the trustability, I think the answer is don't trust anyone in particular. Just trust a lot of people at the same time, and hopefully the bad ones get canceled out by the good ones. That's all I can really suggest at the moment. I think we got time for one more question.
For the previous persons, if you're working in certain fields, you will be told who to trust by your customer.
Yeah, that's a good point too.
They have a booth out there if you want to talk to them.
All right, well, thanks everybody.